you know? And I didn't even remember, quality.
Can we make a movie out of it?
It's a documentary.
Oh, you got to
We're watching it?
Doesn't that make it a murder?
Yeah. So Brendan Dassey is very low. So
The cops pissed me off in that whole part. That episode is making a murder. Isn't it on Netflix?
yes.
I know.
Yeah, that's so fucking
It's
big.
about Stephen
Ooh, that's fighting words. That's fighting
Yes, I
words.
dropped my pencil.
You dropped your pencil.
We'll pick it up.
I did not.
Have you heard the song?
How did you get all the way there?
When I get knocked down, I get up again.
I saw it in.
Yes, Lana. Okay. So the last thing that we're going to get into is talking about angle bisectors and perpendicular bisectors. If you remember correctly, you guys, we constructed angle bisectors and perpendicular bisectors. So a perpendicular bisector, let me kind of draw this out for a second. A perpendicular bisector, you're given a line. We did these two arcs, and we found where the arcs intersected, and then we created a line up. That's like a horribly drawn picture. But with a perpendicular bisector, if we can ultimately get rid of our arcs, we created a line perpendicular to our original line at the midpoint, which midpoint means middle. So therefore, the distance from endpoint 1 to midpoint is the same as midpoint to endpoint 2. They're what's called equidistant. Equa has the word, somewhat has the word equal in it, so that means that they're the same distance. So it's the same distance from endpoint 1 to midpoint and midpoint to endpoint 2. And the other thing that we talked about is with a angle bisector, we took an angle, we found these two arcs, and then we drew a line. I told you guys this when we were creating angle bisectors, that it ultimately takes an angle and it bisects it. It cuts it in half. That's the word bisector means, cuts in half. So it's taking this angle bisector and it's cutting your original angle into two equal parts. It's an equidistant angle. So the two angles are equal. And we can take that fact to solve for side lengths. We can solve for x and figure out what they have to be. So the perpendicular bisector here. So we're going to start off talking about perpendicular bisectors. Perpendicular bisectors are saying you have your original line. We found a line that was perpendicular, created a 90-degree angle on that line, and then we have some differentiation. We have some information about our lines that are created. So it says if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So what they're saying is from A to our midpoint and midpoint to B, those are the same, equidistant. It also says that if you have a point on your perpendicular bisector, so if we have P, and we draw our line, we draw a line from P to our original endpoints, those two are equidistant. They're saying the measure from A to P, that created a triangle, and our point from P to P is the same because it too created a triangle. And it's all based on the fact that it created a triangle, it was created at the midpoint, and that P is on the bisector, on the perpendicular bisector. Okay? So it's wanting us to take and use the diagrams to help us with a hypothesis, which means try to help us conclude what we know about perpendicular bisectors. So it says if MP, sorry, did I say that backwards? Look at me, I feel like I'm all backwards today. If PM is a line, we're talking about our perpendicular bisector. So if our perpendicular bisector is perpendicular, remember our upside down T means perpendicular because last I checked that truly is kind of showing you it's a right angle. Shane and Thomas, you can get yourself up a little bit. I'm just as tight as you are, like more than that. Okay? So if our perpendicular bisector is perpendicular to our original line segment AB, then it's saying that the distance of AM is equal to the distance of MB. So we're just saying those distances are the same. AM is equal to MB. Equidistant. So if AM is 5, MB is 5. If he is 10, he is 10. If he is 20, he's 20. He's 30, he's 30.
30.
Okay, they're the same. Then if sorry. I need to like redo my alphabet today. Okay, then if PA is equal to what? What can we show is equal to PA? PB. That's all they're saying. As long as there's a point on the perpendicular bisector, that point to our endpoints have to be equidistant. Since P is technically equidistant, because it's on the perpendicular bisector lies on the midpoint, that means that the distance from each endpoint are also the same. It's like if I did this. I'm talking about the same distance. Here I go. Same place. My arm lengths are the same. That would be really awkward to like this. No, they're the same amount. Okay? Alright. So, using a perpendicular bisector, we're going to use the diagram at the right to find the length of QR. So, here is our perpendicular bisector. Our perpendicular bisector is QS. It's the guy who creates part of the right angle. And our original line segment is PR. So I'm just going to draw that so we know who our perpendicular bisector is and who our original segment is. Original segment is PR. Our perpendicular bisector is SQ. And it says that your perpendicular bisector to your endpoints are equidistant. So that's what these two tally marks mean. They're really no reference to us right now, but I'm just referring to why they both have one tick marked. Tick, tick. Okay? Now it's using the idea. Now Q, we took a line, a point on our perpendicular bisector and went to each endpoint. What do we know if I go from perpendicular bisector to my endpoints? They're also equal. So this side is equal to this side.
So QP.
Say it again. What'd you say, Jason?
QP.
QB.
QP.
QP. What about QP?
It's equal to QR.
Yeah. QP is equal to QR. Now, we're going to substitute. Here's one of your words that I feel like a lot of you struggle with. What do we do? The reason I can now replace values in this expression is because I'm substituting. I'm going to substitute our value for QP. What is our value for QP? 3n minus 1. That's okay that it's an expression. Don't want you to freak out. It just means that they're together. 3n minus 1, they're together. There's something.
Equals
That is equal to, what can we substitute for QR?
5n minus 7.
Perfect. Now, here it is. You've now created an expression. You now have variables. Solve them. You've now created a multi-step equation. So what do you want to start with first? We have 3n minus 1 equals 5n minus 7.
Minus 3n.
Why do you say minus 3n, Jason, versus 5?
Because it's smaller.
It's smaller. Always work with your smaller variable. It'll help you. It'll kind of relieve any of the pressure of a negative. Not always, but the majority of the time it will. So I'm going to subtract 3n from both sides. 3n cancels. I'm left with negative 1 equals 5n minus 3n, 2n minus 7. What do I do next? Add 7. You want to get n by itself, so we're going to add 7 to both sides. Negative 1 plus 7? 6. I really hope by now you kind of know what n has to be. How do I solve for n? Perfect. And 6 divided by 2?
N equals 3.
Now, I do ask you to go plug that back in. Let's verify that is true. You have a lot of opportunity when we're talking about these ideas that vertical angles are the same or corresponding. We have a lot of benefit to figure out if our answer is right. It's a good way to check yourself because I'm pretty sure you guys want to get good grades. So with that effect, you can always take it and check your work, like right off the bat. Since we've talked that these two have to be equal, you can plug our value for n in and see if they're truly equal. So our value for n is 3. So we're going to take 3 times 3 minus 1. What's 3 times 3?
9.
Minus 1?
8.
So we're saying that this side is 8. Let's verify if we get 8 over here. 5 times 3 minus 7. What's 5 times 3? Minus 7?
8.
So what is our length for QR?
8. Right?
8. set up the next one. So, what is the length of AB? It is already showing, here's our perpendicular bisector. Here's our original segment. They already told us that our midpoint, our perpendicular bisector, is equidistant. So that's why we have our tally marks from A to D and D to C are the same. What else do we know about perpendicular bisectors? What's the same? Go ahead, Jason, I can't hear you.
The length
The length, what length?
between the lines.
Talk louder, my friend.
Oh my god.
Hi,
Hi.
I came to get your money.
Okay, are we done, or is it just being
No,
time?
you can keep it, you can keep it next time.
Oh, next Thursday,
That's
okay.
it.
Okay. Anybody else have money to donate today? Oops, I didn't leave that on
What
there.
kind of donation, miss?
I'm like not even here today.
There's always something.
Yeah, that's all right.
Most likely.
Thank you.
You're welcome.
Most likely.
All right,
Money today.
It's just a little bit of my own shit.
all right, guys, let me have your attention.
Kind of scary.
So, the other thing that is equal is if we have a point on the perpendicular bisector to our endpoints. So B to A is also equal to B to C. So B to A is equal to B to C. Solve it. Take a second.
No equals.
It would take a thing. Kind of the same shit you've been doing. See how AB equals to AC? The whole bit?
What's your fucking thing?
You see what you're doing.
Oh,
You see 4x equals 6x minus 10.
Like maybe remember that. You did the right thing.
no, that's what we got it. I think.
You're not wrong. Look at it this way.
Where'd you go this time?
You brought your 4x over. Only reason why we don't. Well, no, that's what. Yes, but look at it this way. We already have an x by itself, so we want to bring him over here. Because technically we want x on one side and we want our whole numbers on the other side. So we want to take care of our 6x. You'll get a better answer than -1. So try it that way.
Wait, this right here?
You already have, technically our end result is to get x by itself. Well, we already have an x by itself. So that means that we want to bring 6x over. And what's the opposite of a -6? Or sorry, +6. -6. So 4x minus 6x is -2. You want to get x on one side, so technically this is what you have. Get a value, get one of them on, you want them on 2 separate sides. Yes.
Oh, that's the one over.
No, we need to finish this.
Is it felony to see you're American citizen or not?
Is it a felony?
Yeah.
I don't know.
Okay, am I right?
Oh, sorry. I'm like, one track mind.
Huh?
It's probably a misdemeanor just to get deported back. Oh, that's your brother.
You already have it. Remember your goal is to get an x by itself. We already have an x by itself. So I want to do something to my 6x to bring him over. What's the opposite of 6x? No. It's positive. Negative. Cancel. What are you left with? 4 minus 6. Then plug it in. Wanting to know the area? 7. Okay, for us to bring down a negative 10. Yes. I heard you. Alright guys, first off, before I undo this and you guys can check your work, Thomas, I am talking. First off, if you get a negative value for x, let's just remind you, we're talking about real life things. This isn't like algebra where x equals -4 is okay. This is talking about geometry and we're talking about a real triangle in essence. Does that make a triangle? Do you guys agree? Last I checked, can we be in debt -10 sides?
No.
That'd be a really awkward triangle. I don't know where the hell you are. Last I checked, I'm on Earth and that's not possible. So if you have a negative variable, go back and check your work. Because this is real life. We're looking at real life scenarios, per se. You guys should be getting positives. The other thing is when you are solving an equation, your end result, your goal, to get x's on one side, to have whole numbers on the other side. X one side, whole numbers. Could be fractions. We'll just call them constants. So variable, constants. Totally opposite sides. So I told you guys first example, like it's okay that it, or always work with the smaller value because most likely it's going to help you get rid of the negatives. You don't have to worry about that. I said, but not always. Here's a but not always. We already have a variable by itself. We have 4x by itself. So since 4x is by itself, I want to keep him by himself. That means I need to take my other x and bring him over. So that's why I subtracted 6x from both sides. I brought down the -10 equals 4x minus 6x is a -2x. I divided both sides by -2, and last I checked, a negative divided by a negative is a positive. And that's where I got x equals 5. When I went and plugged that x equals 5, I got 20 and 20. Didn't we already say that they should be equidistant, that they should be the same? Okay, I just verified that. Yes, Elizabeth. Yes, did you bring the 4 over and then bring the -10?
I bring the negative.
Yes, there's that way too. There's definitely more than one way, correct. You just dealt without the negatives. Okay. Next thing we have to talk about, we're going to talk about our angle bisectors. So it says that the distance from a point to a line is the length of the Alright, it says the distance from a point to a line. Here's our point. Here's our line. So they're saying the distance from a point to a line. So we can go with the perpendicular line segment. So we can go with the perpendicular, what's what I'm looking for? Perpendicular bisector is also what's considered the short segment. Which is gonna, this is just the idea that you're gonna be talking about a short segment. So they're just saying if you have a point to a line, that the perpendicular bisector is what's considered your short segment. That'll kind of help us. If you guys saw when you guys came in, there was like these triangles up there with multiplication and division coming that's kind of where it's gonna help you in the reference of that. That's all. I thought, hey, why not foreshadow that we're gonna be getting into special right triangles, but just know that. Okay. Theorem 5-4 and 5-5. So this is talking about angle bisectors. So the angle bisector, it says, if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. There you go. So here's our original angle. P, Q, R. This is our original angle. Here is our angle bisector. This is kind of what you guys found when you were doing constructions. We should know how to find him. And I told you an angle bisector is half the original angle. So if we had a 100-degree angle, what's half of a 100-degree angle? We have 250s. If I have an 80-degree angle, I have 240s. So equidistant means, or sorry, angle bisector means cut in half. So I cut the angle in half. So if we have a point on the angle bisector, and we draw that to our angle, wow, that was horrible, a straight line, that we're saying that the point from the perpendicular bisector to our original angle is also what's called equidistant. So if point S is on the angle bisector of our original angle, we want a 3-letter angle, what is our original angle called? PQR. So if angle S is on the angle bisector of my angle PQR, then SP is equal to what? Hey, say it again, Shane. SR. Perfect. We're saying that those two lines created from a point on the angle bisector have to be the same. SP has to be equal to SR. Okay. That's what, I mean, it's the same idea. Equidistant, they have to be identical, they have to be the same. Yes? Okay. It says we're going to be using the angle bisector theorem, and they give us a value for our angle bisector lengths. So let's talk about what we have. We have our original angle. Holy moly. I am off today. So we have our original angle BCD. We have our angle bisector, which is CF. And F is our point on our angle bisector. And we know that the length from our angle bisector to our original angles are equidistant. So what are our two lengths that are equal?
6x.
Okay, hold on. Don't give me the expression. Give me the actual, what is the segment name? FB
And FD.
and FD. Perfect.
Okay, we're
Those
not
two
doing
segments.
17?
Huh?
We're not doing 17?
Already did.
Yeah, it's SR.
Oh, okay.
Sorry, you guys are now freaking me out. All right. Now we can actually substitute our values. What is the expression for FB? Perfect. 6x plus 3 equals
4x plus 9.
4x plus 9. We've now created a multi-step equation. So how do we start? Remember, we want to get our variable on one side and our constants on the other.
Subtract 4x.
Minus 4x.
So perfect. Let's subtract 4x. Here is where it works with you when working with our smaller variable. So we're subtracting 4x. What's 6x minus 4x? 2x. Bring down my plus 3 equals my 9. Now we have x on one side, so now we want to get our constants all over there.
Subtract 3.
I'm going to subtract 3. So 2x equals 9 minus 3? 6. I hope again that you guys can see what we have. How do I get x by itself? Divide by 2. So therefore x has to equal 3. Now they're equidistant. If I go back and I plug in my value of x into my expression, they should be the same. So let's see if that's true. We have 6 times x. X is 3 plus 3. What is 6 times 3? What's 18 plus 3? 21. So we end up with a length of 21. We have 4x. Instead of x, I can plug in 3 plus 9. What's 4 times 3?
12.
12 plus 9?
21.
Are they equidistant?
Yep.
All right, I want you guys to try number 2 on your own. Oh no, I can't see where I'm at. Yeah, I'm writing over it. Yeah, there.
They're like white, red.
Yes. What? Number 2. I said right on your own percentage. Now plug it back in, tell me if those are equal. Plug it back in.
But
Tell
you
me what you
put
get
them
for
on
your
shoes,
degree.
no, I just put them up.
Oh,
That's great.
Right.
so like these.
Huh, we're supposed to be attempting number 2. I can bring a diaper and wipes tomorrow if you need me to.
Fucking for McDonald's. For myself.
You make a phone call.
I'll let you go a couple minutes early.
Oh yeah, no, yeah.
What are you doing?
Talk about shoes.
Okay, so you're saying that Rm is equal to Rp. What is the value for Rm? So 7x equals, what's our value for Rp? Okay, why did you erase it? You got what? Oh, they're not plus, they're equidistant, they're equal, yep. Okay, now, remember, you want x on one side and you want your constants on one side. Do we have a constant or an x by itself, right? Last I checked, that 7 is totally all by itself on one side of the equal sign. He's on the left, all by himself. So that means since we already have an x by itself, we want to bring him over to him. How do we undo a 2x? Nope, he's already positive. I'm going to subtract 2x. Now how do you get x by itself?
Yeah. Yes. Oh my god.
Are you stuck on what 10 plus 25 is? Oh, pretty much that. All right. So when you set them equal, I know you guys already know it. I know this ain't hard. So when you set them equal, we're saying that they are equidistant, that they're the same distance. So Rm is equal to Rp. I've substituted. I plugged in what I did know. So Rm is 7x and Rp is 2x plus 25. I already had an x by itself on the same side of the equal sign, so that's why I brought the 2x over. To undo a positive 2x, I subtract 2x. I got 5x equals 25, and then I divided both sides by 5 to get x equals 5. After I found my value of x, all I did was plug it in to make sure that these were truly equidistant. And last I checked, 35 is equal to 35. Okay? All right.
I'm asking.